Have you ever wondered how businesses optimize their resources and make efficient decisions? Let's take the example of airlines. The airlines industry is a perfect illustration of the use of operations research. They use it to optimize their crew schedules, flight paths, and even ticket prices to maximize their profits and efficiency. Welcome to the world of operations research. This imperative field provides a systematic approach to problem solving and decision making using advanced analytical methods. Throughout this video, we'll delve into key methods such as the Graphical method, Vogel's method, the corner method, Degeneracy, and the fundamentals of the simplex procedure. These tools are pivotal in helping businesses like airlines make efficient and effective choices. Stay tuned as we dive into the first method, the Graphical method. The Graphical method, an effective tool for solving linear programming problems. You may wonder, how does it really work? Let's unravel this with an example. Consider a simple linear programming problem where a company wishes to maximize its profit Z, which is given by the equation Z equal sine 5x plus 4y. The company's operations are constrained by the following conditions: x plus 2 yon is 100, 3x plus y and 90, and x, y and water 0. Now follow on a journey, a step-by-step process of using the Graphical method to solve this problem. First, we formulate the problem into a mathematical model. In this case, our objective function is z equals sine 5x plus 4y, and our constraints are the conditions I just mentioned, all represented as linear equations. Next, we plot these equations on a two-dimensional plane where line represents a constraint. The feasible region, or the area where all constraints overlap, is our solution space. This space represents all possible combinations of x and y that satisfy our constraints. Now, the final step. We find the optimal solution within this feasible region by moving along the objective function line z equals sine 5x plus 4y. We start from the origin, keep moving along this line until we reach the furthest point still within the feasible region. This point, in our case, x equals sine 30, y equals sine 20, is our optimal solution where the company can maximize its profit. Voila! That's the Graphical method for you, demonstrated with a real problem. Up next, we'll dive into the Vogel's method. Next, we delve into the Vogel's method, a practical tool for tackling transportation problems. Let's explore this method in action. The Vogel's method is a simplified approach to unearthing optimal solutions in operations research. It revolves around penalties. To illustrate, let's assume we have a transportation problem. We start by calculating the difference between the two lowest costs for each row and column. These differences represent our penalties. The row or column with the highest penalty is where we allocate as much as possible. We then modify the supply and demand, striking off the row or column if it's depleted. We continue this procedure until all demands are met. It's akin to strategic chess play, where smart moves can result in the lowest transportation cost. Having demonstrated Vogel's method using a practical example, we can confidently proceed to the corner method. Imagine you are standing in a maze of decision-making, a labyrinth of complex problems and choices. This is where the corner method, a powerful tool in operations research, comes into play. Let's understand how it works with an example. Think of it as a corporate giant deciding to expand its business in new markets. To make this decision, the company uses a graph representing different markets, with each corner of the graph symbolizing new market. The corner method then helps to identify the most profitable markets or least costly ventures by examining these corners. Each corner is a potential solution, a new market to explore, and the objective to discover the most rewarding path. But remember, the world of operations research is vast and varied. Besides the corner method, there are complex concepts, degeneracy, and the simplex procedure. These terms may sound formidable initially, but stay tuned. We'll be dissecting these in our forthcoming videos, transforming them into manageable segments. And just like that, we've used a practical scenario to illustrate the corner method in operations research. Remember to like, share, and subscribe for more content like this. And don't forget to visit our website beawarechannel.com for premium content and more thrilling stuff.